So, if you're building software today, you're caught in this constant tug of war, right? On one hand, you need data to create amazing products. On the other, you have this huge responsibility to protect your users' privacy. It's a really tough balance to strike, and in this explainer, we're going to show you exactly how to get it right. This quote right here, it just nails the core challenge. The goal is to remove the identities, all that personally identifiable information, or PII, but somehow keep the data useful enough to power your features, your analytics, and especially your AI. That's the tension we're going to unpack. And that really brings us to the big question for every single developer, product manager, and builder out there. How do you do it? How do you protect people without completely crippling your own product? This isn't just about ticking a compliance box. It's about building trust. And we're about to lay out the playbook for solving this. All right, let's dive right in. To solve this problem, you first need the right set of tools in your toolkit. So we're going to start with the 3 fundamental techniques that are really the foundation of any good data privacy strategy. First up is masking. Honestly, the best way to think about this is like a digital black marker. You're just permanently covering up sensitive parts of the data. It's simple, it's fast, and this is key, it's irreversible. Once it's masked, it's gone for good. This is perfect for when you need to show partial info, like the last 4 digits of a credit card, where you never actually need the full value again in that specific context. Next, we've got tokenization. Now this one is more like a super secure code check system for your data. You hand over something sensitive like a social security number, and in return, you get back a totally meaningless token. The real data gets locked away in a separate, highly secure vault. You can pass that token all around your system, and it's useless on its own. Only with the right ticket or key can you go back to the vault and get the original data. And rounding out our top 3 is hashing. You gotta think of this one as a one-way street. Data goes in, and a unique, fixed-size string of characters comes out. You can never, ever reverse the process to get the original data back. So what's it good for? Its real power is in verifying things. It's perfect for stuff like passwords. You don't store the password itself, no way. You just store the hash. When a user tries to log in, you just hash what they typed and see if the 2 hashes match. Simple and secure. So let's put them side by side. When you look at reversibility, it's pretty clear. Masking and hashing are one-way trips. They're irreversible. Tokenization, though, is reversible, and that choice has a huge impact on data utility. Because you can get the original data back, tokenization keeps the data's utility super high. Hashing, on the other hand, keeps the least. So which one do you pick? Well, it always comes down to your specific use case. But here's the thing. Just knowing about these tools, it isn't enough, not even close, because the real world of data is messy and PII is just notoriously tricky. It pops up in places you'd never expect. There are these hidden dangers you absolutely have to plan for. You're basically walking this tightrope. On one side, you've got false positives. This is your system being a little too paranoid, redacting data that isn't actually PII. The result, your application breaks. But on the other, much more dangerous side are the false negatives. This is the one that should keep you up at night. It's when your system misses PII, letting it slip right through the cracks. And that is how data leaks happen. Getting this balance right isn't just a nice to have, it's absolutely critical. And that brings us to the real kicker. PII doesn't just live in a nice, clean database column called user email. No, it leaks. It hides everywhere. It ends up in your system logs, in temporary caches, in the prompts you send to AI models, and even in plain old error messages. So if you're only looking in the obvious places, believe me, you are missing the biggest risks. So, with all these hidden dangers, you can't just sprinkle these tools around and hope for the best. You need a system. You need a redaction pipeline. So let's talk about a practical blueprint for what that looks like. Okay, 4 steps. First, you have to map out everything. Go on a hunt and identify every single possible place PII could exist in your system. Second, and this is the golden rule, you redact before you log. Seriously. Once sensitive data hits a log file, it's an absolute nightmare to clean up. Third, you sanitize every single AI prompt before it ever leaves your system. And finally, you verify everything. You have to test constantly, rigorously. Your default assumption should be that you've missed something, and then you go looking for it. But, when you pull back, this is about more than just tools and pipelines. To truly fundamentally protect your users, you need a mindset shift, a whole new philosophy for how you build software. And this is it. This is the ultimate rule. Your system's default state, its resting state, should be to not collect, not store, and not process any PII at all. Why? Because the safest piece of personal information is the one you never had in the first place. And this follows right from that last point. If your default is no PII, then anytime you do have to handle it, it has to be a conscious, deliberate, carefully engineered choice. It becomes an explicit exception to the rule, something that you log, you monitor, and you secure like crazy. It stops being something that just slips in by accident. So we'll leave you with this one question to think about. In the systems you're building right now, is privacy just an afterthought, something you try to bolt on at the very end? Or is it the foundation you're building on from day one? Because in today's world, that choice, it makes all the difference.